Alright, this is 5-4 Inequalities. So when we are solving any kind of equation, we are allowed to do a lot of different things. As long as we do it to both sides, then it's allowed, right? We can add 2 on both sides. We can divide by 4 on both sides. As long as we do it to both sides, that maintains equality. And so what we're investigating today is what about inequality? Do the same rules apply for inequality? So we're going to just do a couple of examples on all of these. This first one indicates that if x is less than y, then what if we add a to both sides? Is that always true? So I'm going to just use an example of maybe we're going to start with 3 is less than 5. And on both sides of our equation, we're going to add 2. Then that makes this 5, and that makes that 7, which is true. 5 is still less than 7, so far we're doing good. What about if we start with like 3 is less than 5, and then we add -2 on both sides, which just looks like subtracting 2. That will give us 1 on that side and 3 on this side, which is still true. 1 is still less than 3. So this rule, in fact, always works, no matter what you're adding or subtracting to both sides. The inequality always remains true. So we're going to say that this is always true. Next we have multiplying. So we're going to start out with the same 2 numbers, because why not? 3 is less than 5. What if we multiply both sides by 3? How about? Times 3 on both sides. That gives us 9 on that side and then 15 on that side, which is true. 9 is less than 15. So far we're doing good. What if we were to multiply by a negative number, though? What if we do times -2 times -2? 3 times -2 is -6, and then 5 times -2 is -10. That is no longer a true statement. -6 is actually bigger than -10. It's to the right on the number line. So this is actually no longer true. So the answer for this one is it's only sometimes true. The bad things happen when we multiply by negative numbers. This is a sometimes. Let's try dividing. So what if I'm going to start with better numbers so we can divide them. How about like 10 is less than 15? If we divide both sides by 5, 2 is less than 3, that's still correct. What if we start with 10 is less than 15 and then we divide by -5 instead? 10 divided by -5 is -2. And 15 divided by -5 is -3, which you might notice is no longer true. -2 is actually bigger than -3. So this also, an error occurs sometimes. An error occurs when we divide by a negative number. This is what went wrong here. So it turns out that the only change to the rules that we're used to, the algebra rules that we're used to dealing with all the time, the only change that we need to make in order to maintain inequality is whenever we multiply, put this in capitals, whenever we multiply or divide by a negative, maybe that should be in capitals too, by a negative number, we need to flip the sign. Almost ran out of room there. Whenever we multiply or divide by a negative, we flip the sign. Meaning if it's faced one direction, like if it's saying greater than, then you flip it to say less than. Same thing for greater than or equal to, and less than or equal to, you just change it to be the other direction. Whenever we, in our process, divide or multiply by a negative, we have to flip the sign. So let's do a couple of examples down here. Like we said, the same rules apply here as if this were an equal sign. So we can almost pretend it is. We're just watching for those specific situations where we divide or multiply by a negative. This is just subtracting. Oh, and it should be adding, actually. I'm going to add 8 on both sides so that that goes away, and then we get 13 on that side is greater than 14x. Then we have to divide by 14, and then we get this terrible fraction of 13 over 14 is less than x. In this situation right here, we divided, but only by a positive, so we didn't need to switch the sign there. And that is our final answer. So almost identical to just solving equations, except for we have to watch out for those specific scenarios up there. Okay, so next we have negative 2 is greater than or equal to negative x plus 2, all divided by 7. So the first thing I'm going to do is multiply by 7 on both sides. That gives us, that's a positive number, so we don't need to switch the sign. Negative 14 on that side, and negative x plus 2 on this side. Then I'm going to take away 2, that gives us negative 16. Wow, okay. I always tend to get right, so that's right in the middle, and I never know when it's happening for some reason. If I were really good, I would edit out that segment of the video, but I'm not that good, so sorry. Anyhow, the next step is to divide by negative 1 in order to get rid of this division sign, but this right here is one of those situations we were looking out for. We're dividing by a negative, which means that we need to switch the sign to be the other direction. But otherwise, that's the only change. Negative 16 divided by negative 1 is positive 16. And we end up with this lovely answer. We are going to skip number 3 because it is a quadratic and it should only be solved by graphing. So we're going to skip that one for now. But let's turn the page. We're going to talk about graphing inequalities and what that looks like. First of all, graphing inequalities involves shading. We not only have to graph the line, but we also have to we have to shade either above or below the line. So notice here that we have these two options. We shade above or we shade below. And actually, it's really easy to figure out which one you do, as long as you know what to look for. Usually you will have an equation that's either greater than or less than y. And so what you're looking at is the y-axis. Yikes, that's a bad color. This axis right here. And say we're trying to decide which direction to shade from this line. Our equation that I have up here says that y is greater than, right? That alligator is eating the y, therefore y is greater than, which means that we need to shade above the line on the y-axis. So focus on the y-axis and notice that this is the part of the y-axis that's above the line, so we would shade all of that. That's how you tell which side of the line to graph. It can get kind of sketch when you get ones that are pretty steep. You're not sure where above and below is. But again, focus on the y-axis. This one says y is less than, And that means that you find the y-axis and you find the line and you say, okay, where is that y-axis less than the line? And it's down there, so you would shade on that side of the line. So when you have an equation that says y is greater than, you shade above. When you have an equation that says y is less than, then you shade below. Yeah. Next we have whether or not to include the line that we are graphing. So it says, can y be equal to the function? If so, draw a solid line indicating that the function is included as part of the inequality. If not, draw a dotted or dashed line to indicate that the function is excluded. That starts with an E. Excluded. That's still not how you spell that. Excluded from the inequality. So you include if there is a equal sign like this. If it's less than or equal to or greater than or equal to, you include the line and the line is dark. If it's excluded, you'll have just a less than or greater than symbol without the equal to, which is pretty easy to notice if you know what you're looking for. Okay, last one, last page. We're going to practice drawing and shading graphs here. I made it easy for you though because the really light lines there are the graphs of these lines. So what we're deciding is just to shading above and below, or whether it's included and excluded, not or, and. Both of those things we have to decide. So this one says f of x is less than or equal to, and again f of x just acts like y, so we're saying y is less than or equal to x to the third power minus 1. So I'm going to shade first. It says y is less than, so what I'm looking for is the y-axis here, and then I'm asking myself where on the y-axis is it less than the graph, and it's down here. That's where it's less than. So that means I'm going to shade on that side of the line underneath it, which will look like, ooh, it's bigger than I expected. Something like this. There we go. That's my shading underneath the line. And then we just have to decide whether to include the line or exclude it. And we know that if there's an equal sign right here, then that means we are including the line, so that means it's going to be a solid line. Not bad at all. Number 2, first I'm going to decide where to shade. I'm focusing on the y-axis here. And it says that y is bigger than, the alligator's eating the y, right? So the y is greater than, which means I need to shade above the line. See how it's kind of hard to tell whether, if you're just thinking, okay, where is above and where is below? It feels like left and right. But look how the y-axis is above the line right there, and it's below the line down here. So we are only looking for the above the line part, which means we're going to shade on this side of the line. And then we just have to decide if it's included or excluded, and by looking at this, I don't have an equal sign, so I know that it's excluded, so the line has to be a dotted line. There we go. So that's my dotted line. And finally we have number 3. This is a to the power of 6 equation, so that's something we definitely have not graphed before. However, we have the graph on there. We just have to decide on above or below and include or exclude. So this function is saying that y is less than, so we should be shading below. So on the y-axis, below the graph is down here. So we're going to shade beneath the graph. Down here. Too small spaces for me to get. Oh, okay. It's gonna be as good as it's gonna get. And then include or exclude. In this case, it's exclude because there's no equal sign there. So I'm going to make a dotted line. There you go. And that's all I have for you today.